Hello folks, we are once again back with the miscellaneous exercise, and now we are going for the core problems in the miscellaneous exercise. Now we are going to the problem number 9. The problem number 9 says that a tank with rectangular base and rectangular sides, so it's a cuboid, yeah, opens at the top, is to be constructed so that its depth is 2 meters and the volume is 8 meter cube. If the building if building of the tank costs rupees 70 per square meter for the base and rupees 45 per square meter for the sides, what is the cost of the least expensive tank? So it's a cost which you have to take as your function, and it's on that we are supposed to work. Now it's been very clear from the question that the tank is open, so we have to, though it's a cuboid, we have to work with the base and the sides. And for the construction of the base, there's a certain rate, and for the sides, it's a certain rate. So basically, it's that we have to find out the area of the base and we have to find the area of the sides, multiply with the cost, and that will give you the cost. And that cost you have to work on so as to make it least expensive. So that's how it is. We can just have a brief figure of this tank. Probably this is your base, and then we have the sides as we generally do it. This is our cuboid. Yeah, yeah. So the base and the sides. So that's how it is. Now they give us certain data. They tell us that the volume they have given us, and they have given us a height. So with the help, depth actually, but that's a height. So with the help of that, that will be probably helping us to get certain things, and that way. So just to start with, let's introduce everything about the tank. Let this be the length, let this be the breadth, and this be the height, and areas and so on. So we'll say that let L B H A V be the length, width, height, or in this case you call it as depth, area, volume of this tank. Yeah. Now it's given that the volume they say is 8 meter cube, and the height or the depth they give us as 2 meters. Now we all know that volume is always area of the base times height. So that way it's easier to calculate the area of the base times height. Height for us is 2. So we get the area of the base as 8 over 2, which is 4. So the area of the base is 4. Now, let's work with that further. The area of the base, it's very clear from the figure that the base is made up of the sides are length and breadth. So therefore, the area of the base, you can call it as, which is 4, is also length times breadth, which is 4. This we may need to shift one in terms of the other in some later steps. If we require it, we do it, or let it be there. Now, it's all about the cost. And in the cost, as I told you, the base has got a certain rate and the sides have got a certain rate. So let's find out the area of the base. Area of the base, we have it. So we don't have to find it. We have it as 4. Let's find out the area of the sides. So what is the area of the sides? Area of the sides is going to be the 4 sides. So this side, for example, has area base into height. So also this side. So base into height, you have 2 sides. This side, the side that is standing in front and the side that is there behind, its area is length into height. Even the side behind, that is length into height. So there are 2 sides whose area is length into height. That is why we write twice LH. So basically the area is going to be 2H can be common, L plus B. And H we know it's 2. So that's going to be 4. 2 times 2, 4. See, I have told you that it is going to be the cost, and every time the base you are going to multiply with the rate, and the sides you are going to multiply with the rate, and cost is a function that we are going to work on. When we work on with that function, there is going to be a problem because L and B will work as variables, and we don't want 2 variables, so we will quickly use this. and here L, we will keep it maybe as it is, and B, let's call it as 4 over L, so that we are reduced to one variable. Now, this is for us to find out the cost, and cost C is base, the rate is 7. So you can write rate of the base times area of the base plus rate of the sides times area of the sides. That will give you the cost, isn't it? They give you the rate and you have found out the area. You multiply it, you will get the cost. So the rate of the base is given as 70 and area of the base we have found out is 4. So also the rate of the sides they have given it as 45 and area of the sides we have found out. It's not so good as this. Here there are variables coming. 4 times L plus 4 over L. So it is for us to work on this and to get the function. So C is our function. C is going to be 280 plus 45 times 4. 45 times 2 is 90. 90 times 2 is 180. I think we could take it like that, 180. L plus 4L. Fine. Now we are ready for differentiation and all that. Why? Because you have got the function ready and you have got it in terms of one variable also. So we are ready for the derivative. So let's take the first derivative, dc with respect to dl. 280 is a number, no derivative. Let's go here. 180 times L derivative is 1, and you could call 4 over L as 4 times L raised to minus 1. So that's going to be negative 4 over L raised to 2. That's our first derivative. We require the second derivative also. D squared C by DL squared. Let's see what it is. 180 outside, and then you have, oh sorry, not 180 outside. It's like 180 minus 180 times, so 180, the first term will not have any derivative. So let's go to the next term. It's going to be minus 180 times 4, and this is going to be minus 4, minus we have taken care of, yeah. So it's like 4 times L raised to minus 2. So that is going to be negative 2 L raised to negative 3, or rather minus into minus plus. So it's going to be 360 times 4 over L cube. Let me see whether it is maximum or minimum. Least expensive tank. Least. So you should get minima. We will get it because it's a positive thing. Alright, so that much part is over. Now let's jump back to the critical point. Let dc over dl be equal to 0 for us to get the critical point. So it's going to be 180 times, it's going to be 180 times 1 minus 4 over L squared equal to 0. Let the 180, divide both sides by 180 so that the 180 gets eliminated, and you're left with 1 minus 4 over L squared equal to 0. Let's take the 4 over L squared on the other side. So you're left with 4 over L squared equal to 1, and your L squared becomes 4. That way your L value is plus or minus 2. But length can never be negative. So therefore you have L equal to 2 is the required value. Is the required value, since the negative length cannot be negative. This is not what is a question. You have so many things to do. First of all, you have to check for minima. Then next is what is the cost. They ask you the cost, so we have to find the cost also. So from here, so L is there, so let's calculate the B also and keep. B is going to be 4 over L, so it's 4 over 2, 2. Both are ready with you. L is there, B is there. Now let's ensure whether it is minima or maxima, and then let's calculate the cost. So for that, let's move over there. Let's ensure if it's the minima, and then we will check the cost also. So therefore, d squared c over dl square at L equal to 2 or B equal to 2, whatever that you want to check. So d squared c, it's going to be 30 L. Oh, I'm not, it is 360 times 4 over L cube. Okay, so 360 times 4 over L cube means 2 cube. So after all, it's going to be a positive value. So therefore, minima occurs. Okay, now quickly after that, let's go on for the cost. Therefore, the cost. Okay, and the cost is what? This. So it is 280 plus 180 over L plus 4 over L. Let's quickly substitute the value. L for us is 2 plus 4 over 2, which is also 2. So 2 and 2 it's 4. So 280 plus 180 times 4. Now 180 times 4 is 720. So 280 plus 720. So that way it will be rupees 1000. So cost of the least expensive tank is rupees 1000. So that's how we work out. Very free flowing. It's not, there's no so much of obstacles there. It just flows quite well. So this is how we go about it, and you get the least expensive cost, the cost of the least expensive tank as rupees 1000. So that's all for this video. The next problem, let's meet in the next video. Thank you.